Okay, hello everyone. So in this video we're going to describe a general method for solving equations of this form here. The technique is to make an appropriate substitution, and given any such equation we can always let u equal ax plus by plus c, which is just the linear term inside the f here. Okay, so the effect of such a substitution is that it's going to make our equation a separable equation. We'll be able to reduce this differential equation to a separable one and then just solve the separable equation. Okay, so if u is equal to ax plus by plus c, then we can compute its derivative, du dx, which will just be a plus b dy dx. Now, our objective, of course, is to make the substitution. So we need to get dy dx alone. And we can do that just by having dy dx equal to 1 over b multiplied by du over dx minus a. All right, so now we can do the substitution and then solve for what is du dx, and you'll see if you just do that, you'll get du dx is equal to b times f of u plus a. Okay, and this here is a separable equation. So we can solve it. All right, so let's illustrate this technique on an example. So if we consider this equation here, I claim that this equation is in the form as we said earlier, and the way to see that is that we can just rewrite this equation as 1 minus x plus y divided by x plus y, which is of course equal to 1 minus u over u, where u is just x plus y. Okay, great. So now, doing this substitution for u, we just get that du dx, which we just computed earlier in the step earlier, which is b times f of u plus a. So just to write that again, it's going to be b times f of u plus a. In this case, the b is 1 and the a is 1, so this is just going to be f of u. And what is f of u? It's just this expression, right? So this here, let me just isolate it quickly. So this here is our f of u. So we'll have b times f of u, which is 1 minus u, all over u, and then plus a, which is also 1. And then this is just equal to 1 over u. Okay, nice. So here we can just solve this equation. So du dx is equal to 1 over u. So in other words, u du is just equal to dx. And this just means that a half u squared is equal to x plus c. And again, we just get u squared, just multiplying by 2, we'll get 2x plus. Now, I'm going to write 2c and then change it. So 2c, what is c? What does c represent? It represents an arbitrary constant, which means that it can be really any value. So if c is spanning all values, then 2c is also spanning all values, right? So that for that reason, we just write c here. Great. Now, here we can just write down the final solution. And we get, okay, so u is x plus y. So we just get x plus y squared is equal to 2x plus c. And if we wish to have a formula for y, then this will just tell us that y here is equal to square root of 2x plus c minus x, or y is equal to the negative of the square root of 2x plus c minus x. Great, so these are our two solutions here. Just remember, always when you're taking roots, there is two ways. There's a negative and a positive component, which gives us, in this case, two different solutions to the differential equation, two different kinds of solutions. All right, let's do one more example. So we're going to solve this equation here in a very similar way. So we have, beginning with this equation, dy dx is equal to sine of x plus y. But then we can write sine of x plus y as sine of u, where u is just equal to x plus y again. Great, and then we have our trick, which is that du dx. Du dx here is just going to be, b, the general formula is b times f of u plus a, which in this case again, b is 1 and a is 1, so this is just going to be sine of u plus 1. So we have again a separable equation, and separating everything, we're going to get that x here is equal to, dx, dx here is equal to 1 divided by sine u plus 1 du. Okay, so in order to finish this, we need to be able to, the solution now is to integrate both sides. So integrating the dx, we're just going to get an x, and that should be equal to the integral of 1 over sine of u plus 1 du. Okay, now this brings up the next question. What is this integral? Now to solve this kind of integral, let's just note that there's a trick involved here, and that is to multiply by a clever 1. So here we'll just complete this integration. By multiplying by a clever 1, which in this case is just going to be sine of u minus 1 divided by sine of u minus 1. Okay, and so here, what is the effect of this multiplying by this particular 1, this clever 1 here, is that it's going to change the denominator in a way that we can manipulate it. So that's the understanding here. We can't really go further with sine of u plus 1. But if we had a sine squared and a minus 1 rocking around, then we could. So here, this integral just becomes sine of u minus 1 over, now here we have a difference of squares, so this just becomes sine squared u minus 1. Great, now sine squared u minus 1 is, thanks to our best trig identity in the world, is just equal to negative cos squared u, so we just get sine of u minus 1 divided by negative cos squared u du. Great, and here let's just finish this integration. Here we'll get the integral of 1 over cos squared u du minus sine u over cos u du. Okay, excellent. So this is where we are, and we can rewrite this if you want. This can be rewritten just as the integral of sec squared u du minus the integral of and I forgot the cos squared here because of this, right? So here we can just have, we just keep it the same. It's easier to integrate this way. Okay, good. And this will bring us to a final solution for this integral. Integral of sec squared is just going to be tan. So here we'll have a tan of x plus y. And then the integral here, you can see, you can actually solve this integral by letting u equal negative cos u, and then du is going to be just sine u times du, and so a u substitution like this will help you solve this integral. And in that case, solving the integral, you'll just get negative sec u, which is x plus y. Okay. Great. So that gives us the integral, and we just have to add the c here. And now we can go back to our solution, to our differential equation. So we're interested in, of course, the reason for doing that integration was just this step here. So by what we've just done, we can have this. So our integral here ends up just being, just giving us this equation, that x is equal to tan x plus y minus sec of x plus y plus c. Okay, so that does it for this video. And the technique here is really just very, very, very simple. One is always going to make the substitution u equal to ax plus bx plus c, and then just solve the corresponding separable equation. Okay, thank you.